Hi, welcome to my channel, where I share my knowledge on programming the DJI Tello drones with Python. Today, we're going to learn how to control these drones with a Gamepad controller, in particular, an Xbox One Gamepad controller. We're going to do this using the inputs library, Tkinter, and some OpenCV. Now without further ado, let's get started. Alright, so we're going to start on the GitHub repository, so you know it's there, and you can go to the link in the description if you want to check it out, follow along with me in this video. So here we have Tello Drone Gamepad Xbox Control GUI. Let's go ahead and look at the README and see what we do here. So here we go, we have this project provides a Python-based interface. When we click that, we'll go to our GUI module for controlling and capturing video from a Tello drone. We're going to use these libraries, and one I really want to point out here is we're going to use the inputs library to receive input from our Xbox Gamepad controller. Now, this is why this approach is different from anything you're probably going to find out there, because we're not using Pygame, and that's it. I feel like I'm always finding Pygame approaches for Tello drones. I want to use Tkinter, a built-in library, and not have to rely on learning all the intricacies of Pygame, because I don't want to. Well, not now at least. But, so, inputs library, I digress. So let's go ahead and see. Notes, this project was created using this repository as a template for the GUI. Let's go ahead and open this repository. Tkinter Tello Drone Controller. If you remember, this was video 3 in our drone controller for the Tello for the Tello drones. And the third video, we took flight by binding flight commands to key presses on our keyboard for our Tkinter control GUI. So we're going to use this as a template. And by that, I mean we're going to basically go through and we're going to get rid of some things, and then we'll use that in our PyCharm environment and add some things, which we'll go to together. So what are we removing? Well, let's see. We have our class drone controller, that's all going to stay the same. The initialization though is going to change. See this hidden input frame? We don't need it anymore because we're not going to be using our keyboard to control the drone. We're going to be using inputs library and the Gamepad controller. So we're going to get rid of that. We're going to keep all of these commands because we still want to initialize our drone and all of its associated things. But we're not going to define a speed for the drone to fly at. Why is that? Well, we're going to define the speed as values on our joystick. So you have 4 directions, and we'll have one of those like up direction be the positive, so forward, and then down be like the negative speed, backward. Without going into more details, that's how we're defining our speed. It's a variable speed dependent on the position of the joystick. We're going to look into that in more detail in the Xbox controller module. But we don't need it in the initialization. And aside from that, we're also going to take out our takeoff land button, because what we're going to do now instead, we still use the takeoff land method below, but we're going to go ahead and take off land with this start button. And while it might seem pretty simple, we do have to do some I'll call it debouncing, because it's kind of like debouncing a button if you're familiar with like electronics and such. But we're going to use the takeoff land method as it is, not getting rid of that. We will get rid of the button. So what other changes? Well, in our run application, we're going to get rid of all of this. By all of this, I'm referring to our packing of the button, and then our binding of key presses to the input frame, and then the packing of the input frame and setting its focus. We're not going to do that. And that's it. We're going to keep our video stream the same, clean up the same, initialization the same. So, having looked at that, let's go ahead and go into PyCharm and look at what we added to the GUI. So here's the README, we'll get rid of that. And if you'll see under the project, we have GUI PY and Xbox One controller PY. We don't want to look at that yet. Let's open GUI PY, see what we added. So, as I said, we eliminated some things, but we're adding things. In the initialization in particular, we're going to initialize the Xbox controller object, which we get from our Xbox One controller.py module, and we define the class inside of that as Xbox controller. And here, we're going to initialize it as a part of our GUI. So that's the first addition. Now, we prepare our GUI window, initialize the video stream, prepare a drone object, and get a frame read object as we do before. But one last addition in our initialization, we're going to go ahead and define something self.rc controls. We're going to set it equal to a list of 4 values being zeros. Now, these are going to be storing our RC control values received from the joysticks in this format. So the initial movement velocities are 0, but as they change variably with our joystick movements, we're going to go ahead and send these commands to our drone as RC commands in the format left, right, forward, backward, up, down, and yaw, where left, right, forward, backward, all of that is dependent on a positive or negative speed. So forward would be a positive speed, back would be a negative speed. And it's similar to how we did it in our flight commands from that previous keyboard control, but again, different because a different class, and we're not doing keyboard binding. So let's keep that in mind. So moving on, takeoff and land stays there, but we add a new method. Call this update joystick. We're gonna go into detail on this after we look at the Xbox controller class. But for a quick overview, we're gonna read the values. We're gonna unpack the values to get the ones we want, which are for now just joystick values and our start button. We're gonna do some stuff to map those values to our classes list to hold them in real time. And we'll go into more detail after we look at our Xbox controller class. So one last thing, our run application method, we had to add something new. So we have our new object and our new list that are a part of our GUI class. Those are going to be used for receiving inputs and storing inputs in real time. So then we have this update joystick method. It's kind of like the intermediary between those two. So this is going to kind of receive the inputs from that controller and set them in our list. Now, if you remember, our main loop occurs in our run application method here, where we before updated our key bindings and received our inputs from our keys. Instead of doing that, we're going to get our update joystick values in the main loop. So every time the video stream's updated, we're going to update those joystick values. That's simple as that. Not a lot of changes, but we took a few things out, we added a few things. So like I said, we'll go into this method here in a minute, but it's going to help to get a better idea of that class first. So let's open Xbox One controller.py. So this module contains the Xbox controller class used for receiving inputs, etc. The important facts here are that we're going to normalize the values returned from the joystick inputs, and we're going to filter any low values and consider them to be noise. Now, I will first return here to the repository. So here's the source I found the Xbox controller class template. So I added on to it a little bit, but when you're approaching a project, your best friend right now, because we live in present times, is the internet. We have all this information at our fingertips, and it's really just up to us to learn how to take what we find on the internet and translate it into our exact specific requirements for what we need it to do. So I Googled how to receive input from an Xbox controller using Python. Try to keep it simple and you'll get what you need, really, more likely. Now, if I looked up for Tello drones, this and that, probably find a Pygame approach to receiving inputs, which I don't want. So here I found this Stack Overflow thread, and what I'm concerned with and what we take is this right here. So we're going to use the inputs library, and we're going to import from it the Gamepad. Now, we're going to take this class here, which uses that and initializes some stuff, reads the values, monitors the values, and we have a true loop that basically when we run it, we just read the values. So we took that and we made it our own. How do we do that? So here we have Xbox controller object. Now, first we assign some constants for max trigger value and max joystick value. We're going to go into those in a little PowerPoint because at first it's confusing, but we set them equal to 2 to the power 8 to the power 15. Quite large values. We'll understand because we're going to end up experimenting with the controller to understand how these are set and why they're set, and etc. So past that, we're going to go ahead and initialize this class with a mapping. Well, it's not quite a mapping, but it kind of is. So basically, we're taking all of the possible input sensors, buttons, D-pad, joysticks. We're gonna take all of those possible and we're gonna initialize them as part of this class so that we can have access from them when we use that get gamepad method. So we're gonna set them all to 0, of course, because we're initializing this and we're not reading input until that method's called. Now, below here, we have a monitoring thread, which monitors the controller, sets the daemon to true to keep that going, starts it. So, I'm not gonna go into details here. This basically uses the threading to monitor the inputs received. Now, our read method. So, all we're gonna do here is we're gonna return the current input values. As you can see here, we simply wrap all of those initialized values in a list and return it. Now, those won't be 0 necessarily when they're returned because we're gonna call this read method, pass these ones, and monitor controller, which is what we started that thread on. So, might make a little more sense now. So monitor controller, we execute an infinite loop where we are gonna use that get gamepad method to get the events received from our controller. And then we're gonna loop through those events and we're gonna check which sensor or button, whatever it was received from. Now this is where we go into some more details because this is the last method. And let's just start that way. So event code equals all of these. Now, it's kind of self-explanatory. The triggers we don't need to do. I must have added that in a long time ago, and in a future video we will use this because we're going to add more functionality and be able to execute more advanced commands with different button presses. But for now, we're concerned with our joysticks. So we have 2 values for each joystick. Our right joystick has XY values, XY plane, 2 dimensions. It's hopefully explanatory. And left joystick similarly, XY values. So when we receive these, if that's the event code belonging to that key, well, we're gonna go ahead and we need to normalize the input to be within a range of -100 and 100. So why? Well, it's not gonna be in that range. It's gonna be in, I'm not sure the range off the top of my head. If we tested it, we'd see. But what we want for our drone, because in the SDK, the speed can be defined as any value between, I think, 0 and 100, or -100 and 100, because we're doing the forward-backward of RC controls. But regardless, if you want to watch that speed video, maybe I did a little better than that. But we want our max speed to be 100 and stopping to be 0, and our max speed in the opposite direction to be -100. So that's what we use this normalize for. Let's look here. So we take the value received from our event for that joystick, and we're gonna go ahead and return it as an integer where we divide that value by our max joystick value and we multiply it by 100. So I guess that answers my question before. So what are we gonna get if we don't normalize our values? We're gonna get our max joystick value, which is 2 to the power of 15. We'll go into the PowerPoint a little bit on that more. So I'm gonna save myself sounding like I don't know what's going on. Save that for the PowerPoint. So we're gonna normalize whatever that really large 2 to the 15th power value is to a range between 100 and -100. We're gonna turn it as an integer, not a float, because that's how we pass values to the drone. So we normalize it, that's good. But we also had that nested in this filter noise, where we took the value in and we checked if the absolute value of that value, because we're wanting to filter out lower values. So negative speeds are in one direction, positive speeds are in the other direction. Regardless, we want to filter out any speeds below a certain value, which we decide to be 15. So we're gonna go ahead and take the absolute value so that we get just that speed. And if it's less than 15, we're gonna set it to 0. Why? Because if we don't, this is like debouncing a button in electronics. Let me put it that way. We're gonna be receiving input that's not really there. It is there because they're just so sensitive, especially this one because I've dropped it a lot. But probably because I've dropped it a lot. It's gonna be reading just the slightest input in one way or another, even if we might not be pressing the button. We don't want that to happen because our drone will be just moving all over. So we're gonna filter out those values. hopefully that's self-explanatory enough. So how did we kind of figure this out? Through experimentation. I'll show you some little videos on this next. But one last note, because we'll have another little video on that, is our start button. So where do we get our start button? Right here. Self.start equals to event.state. That's it. So it's gonna be a 1 or 0. 1 on, 0's off. Now, we're gonna do something special in our update joystick method of the GUI class, and we'll look at that video here. But before that, let's go ahead and see how we really found the max joystick value, understood it, put it in practice. Okay, so it's time to figure out how this max joystick value was found. So in the module, when I got it off of a Stack Overflow thread, this was already in it. This was not an addition. So it was important for me to understand why this was defined as the max joystick value. To do this, I went ahead and I first decided to calculate what's 2 to the power 15. That way we have that on hand. We find it's approximately equal, or it is equal to 32,768. Okay, that's good. So now we're gonna do a Google search. We're gonna look up, how is this decided? Is it standard for each Gamepad controller? Is it standard for joysticks, etc.? And in doing this, I found this thread. So this guy had a question. He's asking, says this is the values he got for his joystick, negative to positive, 2 to the power 15. So he wanted to ensure this was standard for all joysticks. This guy answered essentially that he can't answer the question authoritatively, but he can confirm that this is the range that these values are in. Okay, so now these values mentioned here do match what we have, but it'd be best to confirm this in our code and see that our exact inputs are the same as what we expect. So to do this, we're going to add a print statement in our monitor controller method. Right above our left joystick value, if that event occurs for the y-axis of the left joystick, we're going to go ahead and print the state for the left joystick's y-axis. Nice. So then we'll use this print statement right here. Controller values equals joy.read. That's what's going to use the print statement. So we have done domain in our module where we instantiate our Xbox controller class, and we have an infinite loop that reads inputs from our controller. And by having that print statement there, it's going to print whenever the left joystick's y-axis value was received as an event. Now let's see, running this, I have this little video here. So I went ahead, I have the done domain with just those parts, we ran it, and then with my Xbox controller, the left joystick, the y-axis, I'm going to push it to the maximum. And then doing this, we can see negative, positive values. So closing the program, you can see right here, 32,767. Perfect. And that matches exactly what was wrote in the code. So we understand now how we got this. Good. So to get the max values for normalizing, we print the left joystick Y before normalizing, giving that. Let's reiterate that. Noise. Alright, so hopefully that was informative. Now, as I mentioned, the start button we had to do a little extra stuff with, but to understand what we did, let's first look at why we did it. Let's go to GUI.py. So we're done understanding how we got the joystick values, normalized them, filtered out lower values. So when we update the joystick values in the main loop, we're going to try to get them by calling that read method of our Xbox controller class. And you remember, the read method just returns the current input values for all of those button sensors. So we're going to get all of those values as a list, and we're going to unpack the ones we need. The ones we're concerned with is our joystick values, both in the X and Y directions, as well as our start button. Now, this mapping might be different depending on the controller you use or how you have it set up in your Xbox controller class. But given you're using an Xbox One style gamepad controller and a Tello, whether it's a Tello EDU or Tello Talent, I don't have formal experience with the standard Tello drums, but with these ones, I know for sure this will work. So try it out. So let's go on and dive into what we do with these values. So we unpack them from that list of our current values read from the controller. And what we want to check first is if it's that start button. Because if it's the start button, that was what we want to send our takeoff land command with. So if it was, we're going to send the command and we're going to sleep for 0.15 milliseconds. So right here we're gonna sleep long enough to register the button is not pressed so that no false send LAN command. This is just like the joysticks. There is gonna be some noise. By that, it's a little different. So I'll show you a little clip here, but this noise occurs because when we press that button once, we don't have that sleep in there. We might receive a bunch of ons for the start, and that ends up resulting in the takeoff and LAN commands being sent in session. We don't want that at all. So we have to find the perfect sleep, and we experimented to do so. Let's take a look. Now, for the start button delay, we're gonna start by first commenting out that line we used for understanding why our maximum joystick values were what they were. Because we don't want that printed when we're just gonna wanna print the state for the start button. So we comment that out first. Next, we're gonna use the read method again in our vendor main. So instantiate the controller, start an infinite loop reading from the controller, and then we're gonna get the start button by unpacking it from those read values from that list by specifying the index in the list for that start button, which is in our case 14. So we get our start button from the list of returned inputs, and then we're gonna go ahead and print the start button for sleeping is what it is. Then we're gonna use an if statement to check if that start button was pressed. If it was, we'll print the state. Then we're gonna go ahead and we start introducing a delay. Now, I started with probably 0.05 milliseconds, worked my way up to 0.15, which I found to be perfect. Now, let's see exactly how this was tested in the code here. Well, I have a little video. So, testing this with that delay included, we're gonna go ahead and find the perfect results we need. You can see in the console output here, we'll scroll up to when we got a true for that button. There. So, there's nothing around that. It's just print statements with no event states. Perfect. Because if we didn't have that, well, when we just run it without the delay, let's see. Lots of trues that are not, so false positives. You know what that ends up being? Well, through testing this, I would send the takeoff command to my drone without having this delay included. If the drone would take off, I'd move it and it'd land. I didn't send the land command. Well, that has to do with this noise we're seeing. That one is being sent as true for the start button so quickly in succession that it's registering as a land command right after sending a takeoff. So with this delay, we fix that problem, we're good to go. So let's just see, perfect delay found is 0.15 milliseconds. Noise. All right, so that's how we found it. Experimentation to find the perfect sleep value. Now, we shouldn't have our land command sent right after our takeoff command. Sorry about the web drivers. So we checked the start button. Now we have to update our RC values of the GUI class, which will be used to send these control commands in real time. So we're going to map the joystick values to the specific RC control channels. So for left, right, we're going to let that be the joysticks, the right joysticks, left and right in the X direction. X goes to the horizontal, so right, left. Okay, so then we have our right joystick's Y dimension. That's going to control our forward and our backward. Forward, backward. Nice. All right, next we have left joystick Y. That'll be our up and our down. And then lastly, left joystick X is yaw clockwise, yaw counterclockwise. So that's how we went ahead and mapped them to those RC values in that list up here. So we've gotten them from our joysticks. What do we do then next? Well, we check if they're not zero, because if they're not equal to zero, we want to send that RC control command. And we do that like we did before with the send RC control method of the Tello class. And we pass in those values we mapped to our channels. And if it's not equal to zero, well, then that means it is equal to zero. So we're gonna send the command, RC control command, equivalent to stopping the drone with 0 for all the speeds. After that, you might be familiar with this from our video stream method. We're gonna call the root.after, and we're gonna after 50 milliseconds, we'll go ahead and update that joystick. This delay here, found through experimentation, 50 worked great. If it doesn't work for you, you might need to change it. That's about it. Then we'll have a little exception here. If something occurs, we want to know why and that it occurred here. And that's it. I think we're ready to test things out because we looked at here. We update the joysticks when we do the video stream in our main loop. All right. Well, so let's test it for realsies. All right. So to demo this program, what I have behind me is the Tello drone. And then I have a little station set up here with my Xbox controller plugged into my computer, which is out of view. Now, I have my Xbox controller here so you can see the buttons as I use them. And what we're gonna do is we're gonna just execute each control. So take off at the start button, and then we'll do each direction movement. You'll see it on the screen with my controller there so that you can really register which directions control which movements and kind of get some real-time insights as to how that looks. So we'll go ahead and do that. Let's go ahead and start. All right, I connected the drone with Wi-Fi. It's time to go ahead and hit run on our program and see what happens. So we'll hit run, then we'll bring up the console here. Now come over here, start this recording. All right, then we gotta bring up our window. Alright, so I've messed around enough with that. I think this will work to where I can display the Xbox control. We can see the console a little bit, and you'll be able to see the video that I'm taking here. So, if I have the controller in, we're going to go ahead and hit the start button to take off. Alright. Alright, so there we are. So let's go ahead and do each control one at a time. Let's go up with that. As you can see, the speed is determined by how hard you press. So let's go ahead and center it back here. Go ahead and do down, up, and then counterclockwise. Let's bring it into view. There. So now we'll go counterclockwise. You know what? Let's fly this over to you. Alright, so you should see the drone right there. So, go ahead and go. Alright, so we'll go ahead, let's go ahead and just do counterclockwise, clockwise. We'll go, the drone's facing me, so let's go left, right, and then we'll go bounce it out. Forward slow, forward fast, and backward slow, back fast. Okay, don't crash. Whoa, that was cool. Alright, so that was the basic controls. I'm talking to the drone now. Hopefully this all plays out in the editing. I'm just trying not to crash the drone right now. So as you can see, it works. I don't know if this is going to be worth the boot with the controller here. Let's go ahead and bring it down some, center it just right, let's land it. Perfect. So, that was our basic movements. It was a little hard to capture the basic movements with the controller like I expected because I'm in a really small space and the speed is determined by how hard you push that joystick. So hopefully you kind of understood it from that. Now I've got one other little fun thing we're gonna try, and we'll see if we can manage to fly the drone through this. So we'll go ahead, we'll put this right here. Then we're gonna go ahead. Well, maybe we'll put this right like this. Alright, so you can watch it fly through. And then what I'm gonna do is I'm gonna move this to take the drone off. Right here, if you can see it still. Alright, so we got the program running still. Let's see if we can fly through this square. Let me get around the cords first. Okay. So, let's take off. Now, thinking I'm gonna want to watch it on my GUI to know where I'm at here. Well, maybe not. So that seems pretty well centered. Now I probably should have calibrated it. Well, not gonna work today. So, you saw that little dilemma? I think Tello's okay. Let's go ahead and shut things off. So, I think that flying through a obstacle, such as a square or other shape, would be best suited to use computer vision, because I am not a great drone pilot with an Xbox controller. But this was for another video idea I had, where we could recognize shapes using OpenCV, perhaps the pillow library, because it's a lot faster at finding out. But enjoy the crash. You saw the movements beforehand. It worked great. Our Tello drone can be controlled with our Xbox controller GUI quite well. I would just suggest to take the drone outside if you're going to try to do too much flying here. Or maybe limit the max speed, kind of how we did that thresholding on the lower limits. Now, hope you got something from this video, and I apologize for maybe taking a little longer to get content out. I've been pretty busy, and I've been putting a lot of work into this video because I think it provides a lot of value to anybody that likes Tello drones and wants to control them in a far more efficient way. So, if there's anything you have to say about this, any thoughts, maybe improvements or suggestions, leave them in the comments below. I love hearing from you guys, interacting with you guys. So, like I said, do that. And as always, I appreciate your support. Until next time, have a great day.